Hello everyone. Today let's solve the problem number 211, design, add and search words data structure. Right. So what does the question states here? We need to design a data structure that supports adding words. See here, this one, add words. We need to design a data structure that supports adding words, also searching words with possible dot wildcard. So here, this one I'm speaking of. This dot wildcard in the sense where dots can be matched with any letter. Dot can be matched with any letter. Just remember this one. While searching words with possible dot wildcard, where dot can match any letter, right? So, for example, see here, we have bad, dad, mad, anything, right? So, searching, we have bad, dad, and mad, right? So, searching bad will give us false because bad is not present at all. We have bad, dad, and mad. And searching this one, what we call bad, will give us true, and dot ad will give us true as well because dot can be any letter, right? Dot can be any letter. In this case, we have bad, dad, and mad. So dot can represent this one, either B or D or M. So that will give us true as well, just for the example sake, right? So let me do one thing. Let's initialize sorry let's consider the example one for the approach. So I'll just explain this one directly, right? So this is fine one. One thing I want to explain you before discussing the approaches. See here, this one will give us null actually. This is the initialization part, and return value will be null basically, right? So add word, for add word also it will be null basically. The return value of the add word null. We don't have to return anything while we are adding the word. We are just adding the word, that's it, right? So for the search, this one, the return value is boolean actually. Either it can be true or false. Either it can be true or false. Just remember this one, return value. This one null, this one is also null. For only the search method we have the return value either this one true or false, right? So let's consider the same thing. First example for the this one approach, right? So first thing, let's go with the word dictionary. This is the initialization part, so this is always null, right? So this is fine. Next, let's go with the add word of bad. So we are adding bad to try. So now let's add bad to try basically. I'll just go with B, A, and D. So we have added bad to the try. So let's consider. So yesterday I have said, while solving the problem, we'll always consider root first, right? Then we will be adding the characters to the this one. What do we call? Try basically. We are making use of the, or we will be going with the this one, try basically, try data structure. Just remember this one, right? So this is important, right? So next, what we'll do? We have to go with the add word of dad, right? So we went with this one bad. Now we will be going with a dad basically. Let me go with D here. Let me go with A. This is fine. Again D, dad. And next we have add word of mad. So let's add mad as well here. So I'll just go with M. Let me go with A here. Let me go with D here. This is fine. So we have went with bad, dad, and mad. Next, what we have? We have search. Search of bad here, right? So see here, PAD is present. So first we will check whether the letter P is present, right? So the first letter after the root has to be P. So whether P is present initially, the first character, no, right? So we are starting with this one, B or A or M. The words are starting with either B or A or M within the try. So this will be basically pad is not present, and in that case we have to return the return value of the search is either true or false, right? So we have not found the word pad, so we will be returning, or we have to return false in this case. So this is fine, null. This return value of add word is always null, so this is fine. Now we have false, false, right? So I hope this part is clear. Next, we have search of bad. See here, first we will search for the first character, then we'll search for the second character. A is also present. Then we'll search for the D. So D is also present, right? So BAD is present. In this case, we'll be returning Boolean value true. This is fine. This is correct. Next, what we'll do, we'll go with the search. Search of we have dot AD, right? So dot AD. Dot can be any character, right? So either it can be B, it can be A, the first character they have mentioned dot, right? So dot can be of any character, right? So here we can consider B, A, or M, right? So followed by the ad we have for three words here, right? In the try, three words, either we can consider b, this one, either we can consider a, this one, or we can consider m. So it can be bad, dad, or mad, anything. So in this case we have to return true, right? So this is possible, true. Finally we are left with search of this one b followed by double dot. So first we will be this one, going with the b, so we will be considering b here. Next we have dot, any character we can consider. So in this case in the try we have bad, right? So b, we have only one word that is starting with the character b. So next we have dot, so we will be considering a, we can go with a. Again we have dot, we can consider d here in this case, right? So this word is present in the try. So in this case search of this one bad, we will be giving, or we'll be returning the boolean value true, right? So this is how we got the output, 4 times null followed by false and 3 times true, right? So I hope this part is completely clear, easy, completely easy. So we'll be making use of the try data structure for this one, right? So I hope this part is completely clear, man, right? So now let's do one thing, let's discuss the complexities, right? So as we are completely familiar with the approach, now let's discuss the complexities, right? So for the add word and the search, this one, right? So the overall time complexity for the add word method and the search would be big of L. Both, for both it would be because for the add word it will be big of L, sorry, because per word we are considering, right? So L is nothing but the length of the word, right? So this one is for the add word, so we are just adding the word. For the search we will be going with a big O of 26 to the power of d into L, d into L basically, right? So why it is 26 to the power of d into L here? We are considering the worst case where d is nothing but the number of dots, any number of dots can be present, so which has to be less than or equal to 2 in our case, right? So and it is practically small basically, and this one characters, it can be of any character, right? So we are giving 26 to the power of d into L, simple, right? So overall time complexity for the add word method would be big of L, and the search would be big of 26 to the power of d into L. And what would be the space complexity? So this is time complexity part, right? So what would be the space complexity here? The space complexity, overall space complexity would be big O of n into L, right? So why it would be big of n into L? N is nothing but the number of words, L is nothing but the average length, right? So since each word adds the try nodes, overall space complexity would lead to big of n into L, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of L for the add word, and big of 26 to the power of d into L for the this was search method, and finally the space complexity would lead to big of n into L. I hope the complexities part is completely clear, along with the approach as well as the this one, what do we call, uh complexities, approach and complexities, right? So this is fine. Now let's quickly write the code. Let's start writing the code. First let's go with the try node structure. So I'll just go with a class here. Let me go with try node, so this is fine. Now let me go with try node, this will be children, this is fine. So we are just these are just the links for the 26 character, right? So 26 letters basically, or the characters, this is fine. Now let's go with the boolean value, nothing but I'll just go with boolean is end. So why am I going with the is end? So we have to mark the true if a word ends at the particular character or the letter, right? So that is the reason I'm going with the boolean value. I'm considering the boolean value is end here. This is fine. Now let me go with the try node. Let me go with the constructor part, initialization part, try node. So this one I have to mention parenthesis here. This is fine within the try node. So I'll just assign children to new try node. So this is fine. I'll just give 26 month, and also I'll just go with is end. So this one, let me assign this one to the boolean value false. This is fine. Let me come out of this one entirely. Now let's go with the word dictionary. Before word dictionary method or the initialization part, let's consider, we have to start with root, right? Always when we consider try, so we have to start with the root. So as I've as I had showed in the this one as well, what do we call approach as well, we have to start with a root. So I'll just give here private try node. Let's start with a root, right? So this is fine. Let me come to the initialization part. So here word dictionary, so I'm just initialize the root to new try node. We are creating the instance of the try node, nothing but the root here, root of the try. This is just the root of the try. Now next let's go with the add word method, right? So I'll just go with try node. So node, let me assign this one to root. So this is fine. Now let me go with the for loop. So this one will be character C. So this one will be word. This one char array or the character array. This is also fine. So within the for loop, this one will be C hyphen A. Yeah, this is fine. If node dot children, so this one will be index. This is fine. If it is equal to null, so then what we need to do here, we need to create if it does not exist basically, right? So I'll just go with node dot children here. So this one again of index, this one will be new try node, right? So this is fine, man. We know this. Next, what we need to do, we have to move to the next node after doing that, right? So I'll just assign node to node dot children. Let me pass the index within the array. So this is fine. Finally, what we need to do, we have to mark the end of the word always in the try, right? So we have to mark the end of the word. So I'll just go with node dot here. In this case, it will be is end. So this one we have to assign this one to true. This is fine. Yep. Next, let's go with the search method, right? So let's go with the search method. Within the search method, so I'll just make use of DFS basically, right? So we'll be going with the DFS search. So let me do one thing. I'll write the helper function or the helper method first, then we can just make use of this helper method within the main search method, right? So I'll just go with DFS search. This is fine. Let me go with the string word. This is fine. I'll just go with the anti try node. So this one will be node man. So if I'll just give I equals word dot length, I equals word dot length. So then let's return the node dot isn't means we have reached the end here. We have to check if the word exists or not. So I'll just return node dot is end. So ending character we will check, right? So ending letter. So if the letter what we are searching, so basically if it ends with the same letter, then we have found the successful this one word basically, right? So this is fine as we are going with the DFS, right? So we are going with the depth first search from the first letter to the last letter. So basically we have marked the end of the letter as well. So we'll check whether the last letter is same as well, right? So this is fine. Now let me go with char c equals or dot. So this one will be char at, right? So this one will be index. Let me pass I here. So this is fine, man. So one more thing, one more condition they have given here. So if it is dot, dot can match any letter, right? So they have strictly mentioned in the question itself. So here if c equals dot, then I'll just go with the for loop here for int j equals 0, j less than 20. So this has to be 26, sorry, j plus plus. So this is fine. Within the for loop, let me go with a simple if condition here. Node dot children. So this one of j not equal to null. So this one, did I miss anything? not equal to null, and let me write this one within the if condition itself. So I'll just go with the recursion. Let's recurse here. So this one, let me copy DFS search here. If it is not equal to null and DFS search of as we are recursing, I'll just pass the parameters here. This one will be word I, this one has to be I plus 1, sorry, and also node dot children of j. This is fine. Yep. So within the if condition, we will return true. We will return true. This is fine. We'll just return true. Let me come out of this one entirely. So let's return false here. Let's return false here. This is fine. Next, else if c is not dot, so we will be going with index equals character c hyphen a. This is fine. Uh, the next line is let me write the simple if condition when path when we are not able to find the path, or when path is not found, then we have to return false in that case, right? So let me write the simple if condition for that. So I'll just go with node dot is children or node dot children here, this one of index. If it is equivalent to null, if the path is not found, then we have to return false in that case. Finally, let me return again, let's recurse here. So let me go with the DFS search. So what are the parameters? Word I plus 1. Again, here instead of j, I'll just go with the node dot children of. We have to pass the index. That's it. That's the only difference. Right. So this is fine. Finally, we are done with the helper method DFS search, right? So let me make use of this one within the main method search, right? So here I can just give the return value of the search is this one, right? Boolean value. So I'll just go with the return Boolean value. This one DFS search helper method. So this one, let me pass word. We have to start with the zero from the zero index, nothing but the root basically, right? So this is fine. We are done with the coding part one. So let me format this once and let me hit the run button. I hope this works for all the test cases, sample test cases first. We have the compiler error. This T has to be capital, line number 8. Yeah, this one T, this is fine. Let me hit the run button. Again, 16, this one is capital T. Everywhere I have given small t or what? So this one has to be word dot caret. Word, I didn't mention word correctly. 41, I've considered word, right? So now at least sample test case should get passed. Let's see. Yeah, the sample test case is getting passed, right? So there was some typos basically. Ignore that. Now we have cleared the errors, right? So this is fine. Let me hit the submit button. I hope this works for all the test cases. Let's see. Yeah, you can clearly see here all the test cases are getting passed. Means whatever the code that we have written works absolutely correct for all the test cases, right? So we have went purely with the try, right? So we have made use of the DFS search or the DFS, this one helper DFS method, right? For the this one searching purpose within the try. So we have went with the try as well as the DFS, right? Basically. So this is it for the solution part. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.